So beginning with the same, I will be discussing with you now the entire concept related to linear inequations in two variables. Okay, linear inequations in two variables. Before I move ahead with the algorithm to solve linear inequations in two variables, let's develop certain understanding to the concept. When I talk about ax plus by plus c equals 0, here a, b, c are real numbers, a and b are not equal to 0, right? That means x and y are very much present variables in this particular expression, and both of them are sitting with highest power as 1, because I am already saying a and b, that is their coefficients are not equal to 0. Fine. This represents an equation, not an inequation, but an equation in two variables x and y, but because x and y are sitting with their highest powers as 1, because their coefficients are non-zero as I said, therefore this represents what? A linear equation in two variables. Not inequation, but equation in two variables, that too linear. And if I say ax plus by is less than c, or ax plus by is greater than c, or ax plus by is less than equal to c, or ax plus by is greater than equal to c. Over here again, a, b, c everywhere are real numbers. A and b sitting as coefficient of x and y are necessarily non-zero. C can be any real number. In this situation, you can again see these are not equations, but these are inequations in very much two variables present x and y, because both are present with highest power 1, because their coefficients I am saying are non-zero. Therefore, these are all representing what? Linear inequations in two variables. Okay. So in both the places the common thing was that a and b are not equal to 0, and a, b, c are real numbers. Keeping this in mind, I said any expression of this form is called linear equation in two variables, and any of such looking expression is called linear inequation in two variables. Talking about the geometrical aspect. When we were discussing linear inequations in one variable, geometrically we understood how to represent them on the real line, right? And then inferring the interval which that was standing for. Over here also there is a geometrical aspect associated to it. When I talk about the geometric aspect, I will be understanding the geometric aspect of linear inequations in two variables and geometric aspect of linear equation in two variables. If I talk about linear equation in two variables, what do you know about the geometrical aspect of linear equation in two variables? When I talk about linear equation in two variables, that is ax plus by plus c equals 0, a, b, c are real numbers, a and b are not equal to 0 necessarily. In that situation, I need to consider the xy plane or the coordinate plane. This is my x axis, that's my y axis, this is my origin 0, 0. Any equation which is linear in two variables always represents a straight line. Are you understanding? Geometrically, linear equation in two variables always geometrically, we know this from our previous knowledge of coordinate geometry, it geometrically represents a straight line in the xy plane, a straight line. So because ax plus by plus c equals 0, we are considering as a dummy linear equation in two variables x and y. Suppose the line represented is this. This is the straight line represented by the equation ax plus by plus c equals 0. This means what? What do I mean by geometrically? This is the line being represented by this equation. That means every point on this line is nothing but an ordered pair x comma y. Any point you pick up, any point, it has some coordinate x comma y. All the points x comma y which are sitting over this line, making this line very much existing, if you plug the x coordinate value in place of x over here and y coordinate value in place of y over here, this equation will be satisfied. And all the values of the variables which satisfy a given equation are known as solution of its equation, right? That means this line is nothing but actually the set of all solutions of this particular equation. Okay, so any point which is lying on this line satisfies this very equation. And when I collect all the points which satisfy this given equation, these are all the points. This infinitely extending line from both the sides consists of all the infinitely many ordered pairs x comma y, which when I substitute in place of x and y respectively in the equation gets satisfied. It comes out to be a true statement. So, this equation represents a straight line in the xy plane. Whenever you have a straight line in the xy plane, the entire xy plane is divided into two parts. One is towards this side, another is towards this side. You can see right now this line is dividing the plane into two halves. Now there are two ways in which this division happens. One is when I have drawn the line as dark line. Other is the situation. Let's talk about another situation. Again, that's my x-axis, and this is the y-axis, and this is my origin. Again, I would be drawing the same line, but this time I would be drawing it as a dotted line. This time I am drawing this line as the dotted line. Why I am doing this, let me tell you. Over here, when this is the dark line, that means what? This line divides this plane into two halves. One is this part, this complete infinitely large section. One is this part. What is this part representing? This part is representing the collection of all the points on the line and all the points towards this side of the line. Are you understanding? When I am drawing this line as dotted and considering this, when I am drawing this line as a dark line and I am considering this line as well as this shaded part, that means I am talking about collection of all the points which are lying on this line and on this shaded part. This particular shaded part, not just this shaded part, along with the line I am taking it because I have drawn the line as dark line. So dark line along with this shaded part is known as this closed half space. And this line along with this line, when I take the other half in which this line divides the plane, when I take the other half along with the line, it is known as the other closed half space. Is it understood? So a line basically divides the plane into two half planes, one half plane, other half plane. If you are considering the half plane along with the line, then each of the half planes is known as closed half planes or closed half spaces. Are you understanding? That means one half plane is all the points on the line and all the points in that half plane, and the other half plane is all the points on the line and the points which are lying in that shaded region. Are you understanding? That means if I tell you in mathematical terms, when a line is dividing a plane into two half planes, each of the half planes is represented by this inequality. Ax plus by less than equal to c, Ax plus by greater than equal to c. It says solve for x this particular linear inequation 4x plus 3 is less than 6x plus 7. So if we have 4x plus 3 is less than 6x plus 7, the three rules which are required basically to solve any linear inequation is what? What are the rules? The first rule was you can add anything to both sides of the inequation, you can subtract anything from both sides of the inequation, the sign of the inequation does not alter. Second rule, you can multiply or divide by any positive quantity on both sides of the inequation, the sign does not change. But if you multiply or divide by a negative quantity, the sign of the inequality reverses itself. Less than becomes greater than becomes less than equal to becomes greater than equal to becomes less than equal to. And third one was you can take one term from one side of the inequality to the other side by changing its sign without changing the sign of the inequality. Keeping these three rules in mind, let's begin tackling all the questions. In here, I am interested in doing what? Well, 4x, I will bring everything related to the variables on one side, everything related to the constants on the other side just by using the rules. I am removing, or basically I should say subtracting 6x from both sides, that means 4x minus 6x, and I am also subtracting 3 from both sides. That is not going to change my inequality. 3 will be subtracted from here, so I will be left with 0. 6x is subtracted from here, so I am left with 4x minus 6x. 6x is subtracted from here, so this is 0. 3 is subtracted from here, so this is what you are left with. So 4x minus 6x gives you minus 2x is less than 4. Or 2x is greater than minus 4, isn't it? Because I am basically multiplying by minus 1 on both sides, that eventually led to the reversal of the inequality sign. Now I am basically going to divide both sides by 2. That means I am dividing by a positive quantity. When 2x is divided by 2, you get x. Because positive quantity I am dividing by, therefore inequality does not change. Minus 4 divided by 2 gives you minus 2. And therefore your answer is x belongs to minus 2 comma infinity. Solution set is this. Fine. If you wish to plot it on the number line, you can do that. This is minus infinity, infinity. This is say minus 2. From minus 2 to infinity, minus 2 opens, so there is actually a hollow circle over here because I am not including minus 2. And from minus 2 to infinity, so you just bold this part up. That means everything minus 2 onwards excluding minus 2. Clear? Moving on to the next question we have. Solve 30x is less than 200 for x being a natural number and then for x being an integer. That's pretty nice. 30x is less than 200. Dividing both sides by 30 because I want x alone, then only I can get the solution. If I am dividing both sides by 30, 30 is a positive number, therefore inequality sign is not going to alter. When I divide both sides by 30, 30x by 30 gives me x. Inequality remains the same. Here I have 200 by 30. 6.6. So x is less than 6.6. First part. I want all the natural numbers which are solution of this inequality. All the numbers which are solution of this inequality are those numbers which are strictly less than 6.6. If I want solution in natural numbers, that means I want those natural numbers which are strictly less than 6.6. Natural numbers begin from 1, then it is 2, then 3, then 4, then 5, then 6, then 7 and 8. Which are the natural numbers strictly less than 6.6? The natural numbers which are solution of 1 are what? Which are the natural numbers strictly less than 6.6? 1, 2, 3, 4, 5 and 6. Therefore, solution set in this case is this set. It is these natural numbers which are solution of this particular inequality. Now I want solution in the set of all integers. Which are all the integers strictly less than 6.6? Well, if I talk about integers, integers are what? dot 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 -3, -2, -1, 0, 1, 2, 3, 4, 5, 6 and so on, right. I need to be taking up numbers strictly less than 6.6. That means all the integers strictly less than 6.6 will be what? Solution set in the set of all integers is all these I can take, all these integers are less than 6.6, this is also less than 6.6, and that is it. The next integer would be 7, which would not be less than 6.6, and therefore it won't be a solution of this inequality. These are all the integers, infinitely many, which are solution of this inequality. So in the set of natural numbers you have only finitely many solutions, but in the set of integers you have infinitely many solutions. All these infinitely many integers, -5, -6, -7, -8, -9 and so on, they are all strictly less than 6.6 and hence qualify to be the solution of this particular inequation. Next we have solve this particular inequality. Well, these are actually two inequations given. So it is nothing but a system of inequations actually given to you. So let's write it separately. We have what all we have. One is going to come from here, another is going to come from here. One is -5 is less than equal to 5 minus 3x upon 2. Another is 5 minus 3x upon 2 is less than equal to 8. Solving the system means solve this, find out their individual solution sets. Next step, take the intersection of their solution sets. Whatever that intersection set comes out happens to be the solution of the system. That's the drill. Talking about solving one. What can you say over here? In order to solve this, what do you need? You need to get rid of this denominator. So I will be writing multiplying both sides by 2. 2 is positive. That means inequality won't change. When you multiply both sides by 2, you get, so you can just start this by 5 minus 3x by 2 is greater than equal to -5. Multiply both sides by 2. If this is multiplied by 2, 2 cancels out. You have 5 minus 3x is greater than equal to -10. Now you can add 10 both sides and add 3x both sides. Inequality won't change. When you add 10 here and you add 3x here, minus 3x plus 3x is 0. When you add 10 here, minus 10 plus 10 0, and you add 3x here. So you have 15 is greater than equal to 3x. And the next step, in order to leave x alone, I will be dividing both sides by 3. 3 is positive, inequality won't change. 15 divided by 3 gives me 5. 3x divided by 3 gives me x. And therefore, solution set of first inequality is x less than equal to 5. That means minus infinity 5, 5 closed. Fine. That means if this is 5, I am including 5 and everything before 5 up till 5 is the solution on the number line. Talking about the second one, 5 minus 3x upon 2 is less than equal to 8. Multiplying both sides by 2, 2 is positive, inequality won't change. 2 multiplied, 2 cancels out. 5 minus 3x is less than equal to, this is 16, 8 into 2 is 16. Now I am adding 3x both sides and subtracting 16 from both sides. Adding 3x both sides, subtracting 16 from both sides gives me this. And from here you have minus 11 is less than equal to 3x. When you divide both sides by 3, 3 is positive, inequality doesn't change. Minus 11 by 3 is less than equal to x, or x is greater than equal to minus 11 by 3. And therefore, solution set of 2 is x is greater than equal to minus 11 by 3. So, minus 11 by 3 comma infinity, which on the number line if you plot, this is say minus 11 by 3, I am including minus 11 by 3 and everything beyond it is my solution. I have found the solution set of 1, I have found the solution set of 2, I need to find the solution set of the system. Thus, solution set of the system, solution set of the given system is equal to minus infinity comma 5 intersection this solution set. Fine. How do you actually understand this? In one particular real line only, we are going to plot both the solution sets. Here you have minus 11 by 3 and somewhere here you have say 5. So one says minus infinity to 5, 5 included. 5 is included. So you basically have this complete thing, 5 is included. Okay. Next you have minus 11 by 3 comma infinity. This is also included. And you have from here till here, this complete solid portion. What is the common region? Clearly this is the common region, right? And the intersection comes out to be minus 11 by 3 comma 5. Is it clear? That happens to be the solution set of your given system.